Okay, so the last section in here then is looking at the aldehydes and the ketones, and you've kind of got to go back to the summary of the oxidation. Remember, primary alcohols can oxidize to form aldehydes, which can then oxidize further to form carboxylic acids. The secondary alcohols can be oxidized to form ketones, but no further. And the similarity between the aldehydes and the ketones is basically it's this carbonyl group here and here. Now, the reason this one is an aldehyde, the functional group for an aldehyde, is that basically a molecule with a carbonyl group at the end, or arguably the beginning, of a molecule. A ketone is the functional group for that is this, where the R groups either side are alkyl groups, carbon containing CH3s or CH3CH2s. So the similarities is the fact that they have this carbon-oxygen double bond, which we call a carbonyl. The difference is that the aldehyde has a hydrogen and the ketone has an alkyl group. Because the aldehyde has the hydrogen at this position here, it can oxidize further, whereas the ketone cannot. And that's the key thing on how we distinguish between an aldehyde or a ketone. An aldehyde can oxidize further. A ketone, however, cannot. So we take advantage of that when we're looking at the tests for aldehydes and ketones. What we're essentially looking for is a reaction that will react with the aldehydes but not the ketones. Now, we know that the aldehydes can oxidize further to form the carboxylic acids, whereas the ketones cannot. So very simply, which kind of isn't on here, I could actually still use my oxidizing mixture that I used earlier. I could use potassium dichromate and sulfuric acid, because if the aldehyde is there, the aldehyde will form the carboxylic acid, which means the potassium dichromate will turn from orange to green. If I add the potassium dichromate to the ketone, there will be no change because ketones cannot be oxidized any further. So that would be a very bog standard test in terms of what we've done. But there are two other tests which are the ones that we tend to use to distinguish between an aldehyde and a ketone. The first one is Tollens reagent, and Tollens reagent is often referred to as the silver mirror test. Basically, it is a solution of silver nitrate that is dissolved in ammonia. You will commonly hear it referred to as ammoniacal silver nitrate. And if we think about what's in silver nitrate are silver ions. And it's called the silver mirror test because basically what happens is it forms silver, and it does that by accepting an electron. And remember, that means that the silver in silver nitrate is undergoing reduction, and while it's doing that, it is oxidizing what it's reacting with. And of course, only the aldehydes can be oxidized, which means you will only get this silver precipitate with the aldehyde. So quite simply, the reaction is this. With the aldehyde, you get a silver mirror or silver precipitate formed. With the ketone, there is no reaction because it can't be oxidized further. In terms of the two reactions that's going on, the aldehyde is undergoing oxidation to form the carboxylic acid. As I've already mentioned above, the silver ions here gain an electron to form a silver precipitate. And what you tend to get here is, it's called the silver mirror experiment because you get this mirrored effect on the inside of the tube. And I'll link into this some YouTube clips for you to have a look at that. The second test that we tend to use is failing solution. Failing solution is copper sulfate mixed with sodium hydroxide, and we warm it. Now, in here, the copper in the copper sulfate is Cu2+. Now, this is blue. Okay, So when it reacts, it will form copper 1 plus, and in order to form copper 1 plus, it has gained an electron, which means it has undergone reduction, which means whatever it reacts with will have to undergo oxidation. And of course, we already know that only the aldehydes can be oxidized. The ketones cannot be oxidized. This tends to have a red colour here. So the observations are straightforward, really. With an aldehyde, you get a red precipitate. With a ketone, there is no reaction. Just like before, the aldehyde undergoes oxidation to form the carboxylic acid. The copper 2 plus ions in copper sulfate, which is blue, forms copper 1 plus ions in the form of copper oxide, which is insoluble, which is why we get the precipitate. So both of these are kind of definitive tests, really, for the aldehydes and the ketones. You could use Tollens reagent, silver mirror with the aldehyde, no reaction with the ketone. Or you could use Failing solution. You would see go from blue to a red precipitate with the aldehyde, no reaction with the ketone. But of course, there's nothing to stop you using the oxidation mixture. Acidified potassium dichromate, it will turn green, orange to green with the aldehyde, and no reaction with the ketone because it can't be oxidized any further.